Hello everyone. Let us discuss few advanced problems in matrices and determinants. Let us see a question. If a comma b belongs to R and a square plus b square minus ab minus a minus b plus 1 less than or equals 0 and alpha plus beta plus gamma equals 0, then the determinant value is equals to. The options are ab, 1, 0 and minus 1. Let us see the solution of it. From the given inequality, by multiplying with 2, we get 2a square plus 2b square minus 2ab minus 2a minus 2b plus 2 equals 0, which making into the perfect squares, we get a minus b whole square plus a minus 1 whole square plus b minus 1 whole square. So we know whole square term is always a positive and sum of three positive terms can't be less than 0. So there is the only chance it can be equals to 0. So sum of the positive terms equals to 0 means only the chance 0 plus 0 plus 0 will be equals to 0. So we can conclude a minus b equals 0 means a equals to b, a minus 1 equals 0 means a equals to 1, b minus 1 equals 0 means b equals to 1. So we get a equals to b equals to 1. And given one more relation, alpha plus beta plus gamma is equals to 0, let us assume alpha be b minus c and beta be c minus a and gamma be a minus b whose sum is 0 as per the given condition. So by substituting these values of alpha, beta, gamma and a, b in the given determinant, the determinant reduces to this form, which we can split into product of two determinants as cos a sin a 0, cos b sin b 0, cos c sin c 0 into the same cos a sin a 0, cos b sin b 0 and cos c sin c 0. And we know is a 0 row or 0 column in a determinant, its determinant value is 0. So hence the answer is 0. Let us see one more question. If ABC are the roots of the equation, then the value of the determinant is. Options are 9, 27, 81, 0. Given ABC are the roots of the equation, so by solving the equation we get the roots are minus 1, 1 minus 2 omega and 1 minus 2 omega square. And the given determinant can be written as product of two determinants ABC, BCA, CAB and the same ABC, BCA, CAB, which we can observe one thing, ABC, BCA, CAB into ABC, BCA, CAB can be written as first determinant, I'll keep as it is. Second determinant, I'll interchange R2 and R3. So with that, determinant changes its sign. So we get minus. And that minus, I will multiply to the first row. So by taking the product of these two determinants, we get row into column. If we multiply, we get minus a square plus 2bc. Next you get minus ab plus ab, cancel, next c square. Next you get minus ac plus b square plus ac. So we arrive at this determinant. So we can write the given determinant as product of two determinants. So we can write as det of ABC, BCA, CAB whole square, which you get by expanding a cube plus b cube plus c cube minus 3abc whole square, substituting the values of abc, which you get the value, final value is 0. Next, one more question. If alpha, beta, gamma are the roots of the equation and p alpha, beta, gamma lies in the plane 8x plus 4y plus 3z equals 20 and A is a matrix given of order 3 by 3, then A into adjoint A we need to find. Options are these. Let us see the solution of it. Given alpha, beta, gamma are the roots of the equation, so we can write sum of roots, sum of products of roots taken two at a time and product of roots from the given equation we can write. And next, given p alpha, beta, gamma lies on the plane, so the point should satisfy the plane equation. So we get 8 alpha plus 4 beta plus 3 gamma equals 20. We need to find A into adjoint A, and we know the property A into adjoint A is det A into I. So if we get det A, we can write det A into I. So expanding the determinant of the given matrix, we get alpha beta gamma plus 8 alpha plus 4 beta plus 3 gamma plus 28. By substituting the values of alpha beta gamma as 60 and 8 alpha plus 4 beta plus 3 gamma as 20, we get the final determinant value as 68, which by substituting in the property, we get A into adjoint A as 68,0,0,068,0,0,068. Let us see one more question. Let A be a 3 by 3 matrix which contains 5 A's and 4 B's. Then number of symmetric matrices possible is K. Then the number of zeros at the end of K factorial is. Options are 2, 3, 4, 5. This is one good question. The matrix obtained with 5 A's and 4 B's can be having diagonal elements all contain A's or 1 A and 2 B's. Observe the following matrices in which the diagonal contain all 3 A's and the rest 2 more A's can be occupied by A or at these corners or at these places. The remaining 4 B's can be occupied in the remaining places. So there will be 3 matrices with diagonal contains all A's, and there will be 9 matrices which contains 1 A and 2 B in the diagonal. So 1 A is occupied in the diagonal, rest 4 A's can be occupied in these places or in these last 2 places. So these are the 3 matrices which you get more 3 by arranging the diagonal elements as BAB and by arranging the diagonal elements as BBA. So 3 more in this and 3 more in this form. So altogether 9 matrices. So 3 of these and 9, altogether 12 matrices, symmetric matrices from the given elements we can make. So total number of matrices 12. We need to find number of zeros at the end of 12 factorial. So there is a formula. According to that formula, number of zeros is same as exponent of 5 in 12 factorial. So step value of 12 by 5 plus step value of 12 by 5 whole square, so on, which will be 2 plus 0 plus so on, which is 2 units. So the number of zeros at the end of 12 factorial is 2. Let us see one more question. Let the given determinant is equals to a polynomial of 4th degree. Then we need to find the value of step of a plus b plus c plus d plus e by a plus e. The options are 6, 7, 8, 9. We can observe here from the given determinant, we can put x equals to 1 in the given determinant. We get the value of a plus b plus c plus d plus e as 60. And to get the value of e, put x equals to 0, we get the value of e as 0. And to get the coefficient a, which is coefficient of x power 4, replace x by 1 by x in the given determinant. The determinant will reduces to 1 plus 3x, x minus x square, x plus x square, 1 plus x minus 2, 1 minus 4x, 1 minus 3x, 1 plus 4x and 3, which is equals to a plus bx plus cx square plus dx cube plus ex power 4. Now we can put x equals to 0, we get the value of a as minus 7. So we need step of a plus b plus c plus d plus e by a plus c, which is minus of step of 60 by a is minus 7, e is 0 anyway. So minus of, we get minus 8 point some value, which whose step is minus 9. So minus of minus 9 is 9, its value is. Let us see one more question. A1, A2, A3, B1, B2, B3 are the real numbers, then the value of determinant is. Here the options are: the elements of the determinant are the perfect squares, which you get by expanding a1 square minus 2a1 b1 plus b1 square. So each element is a perfect square, so each element can be expanded. So by observing the elements of the determinant, we can split the given determinant into product of two determinants as this form, which you get by multiplying the row of first determinant and the row of the second determinant. We get a1 square minus 2a1 b1 plus b1 square, which is nothing but a1 minus b1 whole square. Similarly, we get the other elements. So the given determinant can be split into product of two determinants, and we know the value of the standard determinant 1 1 1 a b c and a square b square c square as a minus b, b minus c, c minus a. Based on this standard determinant value, we can write, so we get the answer as 2. We can take common a1 minus a2, a2 minus a3, a3 minus a1 into b1 minus b2, b2 minus b3 into b3 minus b1. Let us see one more question. Let A, B, C, D be real matrices such that A transpose is BCD, B transpose is CDA, C transpose is DAB, and D transpose is ABC. For the matrix S equals to ABCD, which of the following is true? Observe the options. Is S square equals to S, or S cube equals to S, or S power 4 is S, or SS transpose is equals to S. So let us take the matrix S, which is given as ABCD, in which BCD is given in the given question as A transpose. So replacing BCD with A transpose, we get S as A transpose, and A can be written as A transpose whole transpose, which you get S as A transpose whole transpose of A. And substituting the value of A transpose as BCD, we get, taking the transpose of BCD, which you get D transpose, C transpose, B transpose into BCD. And substituting the values of D transpose as ABC, C transpose as DAB, and B transpose as CDA, BCD can be written the same. You get product of ABCD into ABCD, which you get S cube. So we can say S cube is same as S. Let us see the next question. If A1, B1, C1, A2, B2, C2, A3, B3, C3 are 3-digit even natural numbers and delta is given a determinant of third order, then delta is. Look at the options. Divisible by 2 but not necessarily by 4, divisible by 4 but not necessarily by 8, divisible by 8, or divisible by 16. Based on the given 3-digit even numbers, we can apply the transformations. C1 implies C1 plus 10C3 plus 100C2. We get the given determinant, the first column, the mentioned 3-digit even numbers. So which you can write as 2k1, 2k2, 2k3. So by taking 2 common, you get 2 times of the determinant. So we can conclude that the determinant value is divisible by 2 definitely, but not necessarily by 4.